So let's take a look at this problem from 10.1. This is question number 5. We're looking at a scatter plot, and we want to examine the pattern of all 10 points and subjectively determine whether there appears to be a strong correlation between the x values and the y values. Then we want to find the value of the correlation coefficient and determine if there's a linear correlation. Anyway, let's look at these points. All right, so what are the points? Well, I've got the point 2, 1 here, and then it looks like 8, 8, 8, 9, 8, 10, 9, 8, 9, 9, 9, 10, and 10, 8, 10, 9, 10, 10. So what we're going to do is we're going to open up StatCrunch, and we're going to go ahead and enter these points into StatCrunch. So you see I did that there. Then what we're going to do is we're going to go to Stat. Then this is a regression, a simple linear regression problem. So we're going to click simple linear. We're going to tell StatCrunch where our x value is. We're going to tell it where our y value is. And then we're going to hit compute. And then as you see, we have our linear correlation coefficient right here. This is a coefficient of 0.893. And then we have this analysis of variance, which shows us a p-value of 0.0005. So let's go ahead and go back to the problem. Do the data points appear to have a strong linear correlation? Well, the answer is yes. I don't necessarily agree with this because that cluster up at the top kind of makes it look like maybe there's something going on besides linear, but the answer here is yes. Probably because of this point down here, this outlier. The value of the correlation coefficient is 0.893. Is there a linear correlation between x and y? So we're just going to look at this list of critical values. And we have 10 as our number. And for 0.01, a critical value, it's 0.765. 0.893 is clearly more than 0.765. So we have a correlation coefficient in the critical region. And now, what is the correlation coefficient when we remove that outlier? So we're going to go back to StatCrunch, and then we're just going to delete this column. So I think we just right-click and click Delete Row. And now I'm going to go to Options, and I'm going to refresh this since we have made a change to our table. Now we only have a sample size of 9 paired values. And we get a correlation coefficient now of, let's see, we get a correlation coefficient of 0. So let me enter that. So this is a really interesting example. We will remove 1 point, and we go from a correlation coefficient of 0.893 to 0. So having a linear correlation coefficient of 0 doesn't mean that there's no correlation. It just means that there's no linear correlation. And when you take that 1 point away, then this clearly doesn't have a linear correlation. I didn't think it had a linear correlation in the first place, but the textbook is disagreeing with me. Is there a linear correlation between x and y? No, it definitely is not. It's a 0. What do you conclude about the possible effect from a single pair of values? Well, it can change your conclusion. And that concludes this lesson.